Good morning students. In today's class we are going to have the topic Laurent series. So this is one of the topic in complex integration. Okay. So before I enter into the problem, we should know why we are using this, right? So we'll have more number of series, right? That is like Taylor's, Lorentz. Okay. So this is one of the way we are going to expand this expression as a Laurent series. Okay. We'll have Taylor series and Laurent series also. Okay. We can do the same problem in Taylor series also, right? We are going to get the same answer. The problem is expand f of z equal to z minus 1 by z plus 2 into z plus 3 as a Lorentz expansion in the region 2 less than modulus of z less than 3. Okay. So the first thing is I want to take the given f of z. For that we are going to use partial fraction method. Okay. So that is you already know, right? Partial fraction method. The same way I want to apply the concept. So partial fraction method. Okay, yes, the term is z minus 1 by z plus 2 into z plus 3. That should be equal to, this is normal factor. That means a by first factor plus b by second factor. So this way I want to apply partial fraction. Okay, now remark this one as equation number 1. Now we are going to take the LCM, which is z plus 2 into z plus 3. Okay, now take the cross multiplication. So a into z plus 3 plus b into z plus 2. And just leave the denominator. Consider the numerator term, which is z minus 1 equal to a into z plus 3 plus b into z plus 2. Now we need to find the constants a and b. For that we need two values for z, right? We just take the denominator equal to 0, find the value of z. Okay, so the first value is what? Put z equal to minus 2 and substitute here z as minus 2 in both sides. Okay, so the left side becomes minus 2 minus 1 equal to, the right side term is a into minus 2 plus 3 plus b into minus 2 plus 2. So minus 2 minus 1 is minus 3, which is in the left side, and the right side is 3 minus 2, that is 1. 1 into a is a, and second becomes 0, just leave. So from that we can get a value as minus 3. And take the second term, put z equal to, second value is minus 3. Substitute in the same expression, right? The left side is minus 3 minus 1 and the right side is a into minus 3 plus 3 plus b into minus 3 plus 2. So minus 3 minus 1 is minus 4. This becomes 0 and the second term is minus 3 plus 2, which is minus b. So from that we can write b value as 4. Okay, now we got a and b. Just substitute in equation number 1. So equation number 1 becomes z minus 1 by z plus 2 into z plus 3 equal to a value minus 3 by z plus 2, b value 4 by z plus 3. Up to this we already know the concept, the same concept. Okay. Hereafter we just go for the given condition. The condition is what? Yes. 2 less than modulus of z less than 3. So this is the condition. Now we split it as, so in this region now we are going to find the Laurent series. We just split it as 2 less than modulus of z, and the second one is modulus of z less than 3. This way I want to split it as 2. Okay, now we need the condition as less than 1, which is bring the term to the left. So which is 2 by modulus of z, and here it is modulus of z by 3, that should be less than 1. So we need the condition as less than 1. That way I want to bring the remaining terms to the left. Okay, now we go for this term. So z minus 1 by z plus 2 into z plus 3, that should be equal to minus 3 by. So the first factor which involves z and 2. For this the condition, this is the condition. Check the denominator term, that term we need to take outside. Okay, that means z is outside. The remaining is 1 plus 2 by z. The first term is over. Go for the next term, plus 4 by. So this factor which involves z and 3. For this the condition is, this is the condition. Here the denominator is 3, that means I have to take 3 outside. So 3 is outside, means the remaining thing is 1 plus z by 3, and that should be equal to minus 3 by z outside. Write this term into numerator. So which is 1 plus 2 by z the whole power minus 1 plus 4 by 3 and write the same thing in the numerator. That means the power becomes minus 1 and use the expansion, binomial expansion. So that is nothing but 1 plus x the whole power minus 1. Okay, the expansion is 1 minus 2 by z plus 2 by z the whole square minus etc. plus 4 by 3 into, here also we are going to use the same expression. So 1 minus z by 3 plus z by 3 the whole square minus etc. Now we are going to make it as an expansion. So you can write inside the summation n equal to 0 to infinity minus 1 the whole power n 2 by z the whole power n plus summation n equal to 0 to infinity, just 4 by 3 is outside, and we can write the series as z by 3 the whole power n into minus 1 the whole power n. Okay, so this way we need to find the Laurent series. The region is given. Okay, the procedure is just to find the partial fraction method. Then you go for the region. If it is a single region, it's just split like this, and we need the condition as less than 1. Okay, for that just bring all the terms to the left and check the denominator. Take that term outside. Okay, for that I want to check the factor which involves what are the variables and constants. Based on that, if you have the condition, check the condition, and in denominator which variable which is present, so that variable I want to take outside. Okay, then I have to bring like this and use the binomial expansion. After that, you write it in summation. This is called Laurent series. Okay, this way we need to find the Laurent series if the function is given. Okay, thank you guys.